Hello and welcome. I'm Bill Wake. We're working this week on the regular expression compiler. So it's going to be code that generates a matcher for regular expressions. We've done a fair bit of work so far, and I think we're going to wrap it up today. I hope so. I'd hope to finish in 3, but it looks like it's going to be 4 sessions here. All right, so we're based on this article by Doan Ulus. You can pick up a copy at archive.org, our archive with an X. Sequential circuits from regular expressions revisited. And the thing we're trying to do is you're going to give us a regular expression. We're going to we're writing the code for the matcher generator that spits out code. The code it spits out, this is from the paper. He did C++. We're doing Swift, but we're going to use the same algorithm. So I mentioned we've been progressing. Tuesday, we worked on the regular expression parsing. We built a tree. Wednesday, we computed skip functions and out functions that are 2 functions this article outlines. And yesterday, we completed computing the trigger. So it's another function that basically tells you what locations you could be in and go to. So today, we're going to generate some code. I'm hoping we'll do that relatively quickly. I'd like to explore a different generated algorithm that uses bit flags instead of arrays. Let's see if I go back to his code. You know, he's got a int state of 6. We'll use Boolean, but I'd like to explore using bit flags instead of an array. So that's the bonus thing if we get time, and we'll refactor a bit. I've left some slop in there. You know, I'm not perfectly happy about that, but that's where it is. All right, so welcome on Twitch. If you're a new follower or would like to be, there's a follow button down in the corner. You're welcome to follow me. I broadcast Tuesdays and Thursdays 1 to 3 p.m. Eastern Time and Wednesday 9 to 11:30 a.m. Eastern Time. Or if you want to go to xp123.com and you can sign up at the About page or the Update page, either weekly or monthly. The weekly articles tend to be programming oriented. The monthly ones are more general agile topics usually. All right, so we've been working with this running example, A, B, or B star, B, A. And the trigger function I mentioned is this table on the bottom left. And the key insight of all this is, it's kind of like, suppose I see a B, and I want to figure out where am I in the string. Well, one place I could be is 3, meaning I just, A, B, or B, I took the B path. Or I could be in 4. You know, I don't know what's coming yet. I just know I've seen a B. I might be at position 4 waiting for that final A. Or I might be at position 3 with the option to repeat a B or go here for a B. You know, I've got options. And what we need to do is track kind of the simultaneous options that we have. I could be in position 3. I could be in position 4. I don't know. Seeing a B is not enough to tell me. But if I see an A and then end of string or an A followed by a B, I know which one it was. All right, and we're kind of in the midst of this algorithm. We've already computed the pound E, which is the number of letter match tokens. We've computed skip of E, which says for any expression, could it be an empty string? We've computed out of E, which says what are all the positions that you could be based on this expression? And then finally, this trigger function, the table I mentioned, this algorithm is how do you generate the code? Well, we'll have to allocate a vector, define a starting position, define the next state functions, and then define a function that tells us did we match or not, a Boolean function. All right, we'll skip that. We've got that kind of under control. All right, so just showing off where we are so far. So I type in a regular expression. Let's say I do A, and I hit compile. All right, it puts the expression in here because it needs to show it on the right-hand screen. So the blue is our compiler. The green is you take our compiled code and stick it in another program and let the program use it. Okay, so you see the A, and then down here the state vector. And this starts off true, false, true because I am in position 0, the start of the string at the beginning of things. The state 2, I'm setting it the state 0 to false, meaning match only the front, and match this if the character is A. Okay. Now, if I put an A, B, C, D, E, okay, I change expressions, but we don't compile this part correctly yet. And actually, I'm not quite sure this is even right, but okay. So what we've done, we've got this intermediate code structure that contains the original expression that just flows through, the count, the out positions, and the triggers. We're taking that structure, and then our code generation is basically going to take the intermediate code and generate target code, which is Swift code. And you can see I've got the template for it here. I've got, public class matcher, expression equals the original, function accepts, and all that stuff. That's what gets plugged in over here. Let's see, where's matcher? Okay. Public class matcher, var expression equals, function accepts, and then a bunch of stuff. Stuff. Okay. Let's go back. All right. So where we are, we're trying to generate the proper code for things. And I think, I don't know if I'm overthinking or not, but what I think we've got here, I do think of this as being the template for it. And we're going to plug in stuff that fits, based on the actual expressions we're using. We'll have to use these trigger functions and so on. Let's see. So I think what I want to do is some refactoring to start with. So I think 3 things are going on here. One is we're creating the template. The second is we're sort of computing the stuff that belongs in the template. And the third is we're replacing all these things. Okay. So I think we can make a pretty straightforward extraction and do this. All right. So let's run tests, make sure we're green. Classic mistake. And I'm running a Pomodoro timer for 35 or 40 minutes. We'll take 3 breaks during the session here, or 2 breaks, 3 segments. Okay. And also I upgraded Swift Xcode this morning, so I don't know, it seems like it's a little slower, but we'll let it finish testing. And then, we've been waiting 2 minutes here, and it's going to tell us, oh yeah, I did it in 30 seconds. Okay, thanks. Launching. Okay. It is slow to launch the simulator the first time. So unit tests in Swift with Xcode, they run inside the simulator. You don't have to see flash by flash by flash every move, but it does do that. And let's see, we can get the information here. Okay, so 37 tests in 0.3 seconds. Seemed longer. All right. So what I want to do is I basically want to say I'm going to have a builder class. So a builder, you start with this builder, and then you sort of accumulate things you want to do, and then at the end you sort of apply them all and give some result. And that sounds like what we're getting here. It's just kind of mixed in. We've got both things going on, both the calculations and the iteration. Okay. So let's extract a builder for this. I guess that's the first phase. I think, I don't know the right way to do this. Let's refactor. I can't extract an element. Okay, let's call it code. No, we can't use that word. I'll call it builder for now. And then I'm going to make template equal. Let's leave template. And then I'm going to make builder equals. Okay. And then down here, I want to propagate in. Instead of using template, I want to use builder. Oops. Okay, I mean, that's basically introducing a new variable and using it. I don't think there's any Any big danger there. Okay, now what I want to do is I want to say this is code. I'm going to call it code, I think. We use intermediate code already and target code. I think this is what this is. So I'm going to extract a class that takes this, and then I'm going to call make at the end. All right, and make is gonna build the thing up. Okay, and so I'll just put the class here for now. Class code. It's got an initializer that takes a template, which is a string, and it's got a make function, which returns a string. Okay, and then let's make a I don't know, is this body? Yeah, let's make a body of type string, and body equals template. All right, and I guess that can be a let for now, and in the end we'll return body. Okay, implicit. You can use the word return is implicit if you've only do one thing in a function. Okay, so my claim is nothing changed. Everything should still be working. All I did was pass the template in and then pull it right back out. Okay. Okay. Now. My theory is I'm going to let the builder do all those replacings, okay? And I could do it as we go. So let's we don't need make yet. Well, we do. Okay. Let's make this code go in there. I'm going to say with, and then the key is this thing. I don't know, as. Okay. So I'm taking the template with original expression as int code.original expression. Okay. And that doesn't exist yet. It takes a string and an as that's another string. So this is function with, takes a key, which is a string, and it takes an as, which is a string, and it produces, and this is the trick that makes it a builder, it produces itself. All right, and we don't have to care. I mean, it would be okay if it accumulated everything and then applied it. That would be fine. We just care that by the time we get to make, it's there. So I think I will do this. I make body, and we're going to say body equals, and I'm just pulling in the code. So body dot replacing occurrences of key with as. All right. And so my claim is this code is really that now. So builder, let's move the make down. Okay, so I've made a builder, I've done some substitution, and at the end I'm going to do something with builder.make. And at the very end, I'm going to make it return builder.make. All right. This should all pass. Okay, I'm just refactoring. I'm pulling out functions, rearranging them. I don't know if you'd call this a by the book one. I don't know. Let's see. I have Josh Karyevsky's refactoring to patterns. Let's see. I don't know. Encapsulate composite with builder. No, it's not really that. I don't see a formal one here that matches that. But that's okay. I'm doing these tiny steps so I can convince myself that it is okay. All right. So now a state declaration, I can, and let's make this a var, and I'm just going to, I'm going to pull things in more piecemeal. Okay. So if I take the builder dot with as, okay, and I'm going to take state declaration because I've defined that now. And this string is state declaration. Okay, so this can come out. Okay. Whoops. State declaration we just calculated. Could do the same thing here. Replacing, so this will just keep going. Builder equals builder with, and now we want state 2 declaration. As that. Okay, and we'll take this out. And as I get used to it, you know, it's very common that I will speed up on these, but you could definitely break it into smaller pieces, but we haven't. Okay, so let's do body. As body. Okay, and we'll take a break here, check them out. Expected expressions. Oops. Well, that was weird. Try to build again. Maybe hitting. Oh, as is a keyword. With. I'm going to make this with. Don't think that's a keyword. And maybe this is replace with key with value. Replace. Let's rename this one. Certainly not there or there. Okay, I guess it's not going to wake up for me. All right, let's do that manually. Okay, try again. Guess I should have done one or two less steps, and still something wrong. Missing return. Oh, yeah. Okay. Slightly bigger. Okay. Yep. All right. So let's get these last two. We're replacing some key with update state. The key is this. Okay, comes off there. And this one is return value. Okay. And then now I think we can just say builder dot code dot, sorry. Let's just inline this effectively. Is that in my refactoring list? No, come on. Why am I updating if I don't get anything out of it? Okay. Cool. Now, let's make sure that works. Okay. And let me rename builder. I do like this code name better. Refactor rename. And we'll just call it code. Okay. I will say that's progress. Now, we haven't tested this new class, and maybe I just need a little, let's just make sure we get a little bit of that in. So we'll have a class code tests, extends XC test case, and a function test replace. So we'll make a new code. Code is code with a template and hi you, and we'll make this dot replace %u with there. And we should get hi there if we do code.make. Okay, and yeah, that can be all that. Okay, now the other thing I'd like to do in here, and I don't know if I'm being, I don't know if I'm overstepping it, but one thing is this big string, like I'd rather make this thing deal with the strings. So I'm going to put a function in that knows to deal with an array of strings. Call this replace string and call this replace array. And will kind of be the same. Okay, so we'll create a template, hi you, and then I'm going to replace you with an array. Okay, so I'm saying I want to replace this template field or position with an array, and what I intend this to mean is I expect to get it separated by new lines automatically. So I expect to see there, you. All right, so with a new line inserted between them. Okay, it doesn't compile because we don't have that function yet. But let's make it key string, and then this is going to be array of string. And we will not change anything for the moment. All right, should fail. Good. All right, and we expect to get high. Yeah, didn't get substituted. Okay. All right, so what I want to do is body equals body dot replacing occurrences. Replacing occurrences of key with, and then I want this thing to be with dot I guess this is the one I want, join separator. The separator is /n. Okay, so notice the first, there's not a new line before it, is only between them. And I think that's okay. That should pass. All right, and then let's use that. So we're going to make body be an array, and I think we can just do this. Okay, so body state 2 equals false, state 1 equals this, that, and the other. And we'll have to put the slashes in since the triple quote was doing that for us. All right, but I'm using that now, and that may help a little. Should all be working the same. Okay. All right. So I'm going to go to the to-do, generate target code. So I think the first thing we're doing is make a code template builder, and we have done it. So today, okay. Now the second thing I want to do, these things, I would like them to be their own little tiny class, honestly. And I'm thinking, what's the best way to get them there? Again, I don't know. Maybe I can just pull them in. Yeah, that'll probably be a good way to start. Okay, so I'm just going to make another class. I'll leave it in this file for now. Bad habit, right? So this is the, I think it's array generation. Array style? It's array something, because array is already a class. Let's see. How about array code? Okay. And I'm going to just pull stuff in. Like this. And this might have been easier before. So what I'm doing is I'm looking for these small steps that that get me everything I want, and then I'll be able to munge them around a bit. Okay, body, update state, and return value. Okay, so I'm at this point I'm just making constants. All right. Now, certainly there's no harm so far because nothing's referencing it, but let's reference them instead. So let's do let's let array code is new array code. Okay, and we're going to use it here. So I'm going to say array code.state declaration. So in effect, I've just moved the constants out to their own class. We will change that shortly. And I would think body would start they would start complaining, but okay. Yeah, these variables are no longer used. We'll make sure it works. Then I'll clean those up. The reason I'm doing this is I do feel like they belong together in some sense. And having them in one place is a good thing. The second thing on my mind, I'll admit, is I do want to try and get to this Boolean flag approach instead of array of flags, and I can definitely see that having these in one place is going to make that an easier process. All right, but this is okay. Most of the work's going on in array code now, but what I'm getting out of this, I'm trying to minimize the stuff I have to test in sort of a chained fashion. So I have at least we have at least one test somewhere that checks the overall output once, and that's fine, but I would like to modify this and make it so I can just test this thing, assert I get the strings I want, and I already trust that the replaces all work. Okay, so I want to be able to focus my testing here, and again, I think that's reasonable. We'll modify things, but array code tests. Okay, extends XC test case. All right, and function test. Now, maybe I can modify first. So one thing I know is if I'm going to generate the real code, I need this intermediate code to do the job. So let's make it so you can pass that in. What's it called? Int code. All right, and this thing takes an initializer that takes int code of intermediate code. All right, and right now it's ignored. That's fine. Okay, and then I would like these to be functions instead of hard-coded strings. Okay, so I'm going to make this a function returning a string all right, and then whoever used it up here has to call it with a function. Okay, still minimal and relatively safe and straightforward. So state2 declaration It is another function. So I'm just going to move these all to being functions. Okay. Okay, we'll finish the replacements. And I don't know if it really mattered. All right, this should all build and run. So we pulled stuff as constant strings, then we turn those constants into functions that return constants, and now we're going to go in and start making things real. But that timer was the timer for a break, so let's take a couple minutes, 2 or 3 minutes at most, and we'll come back and get this thing moving forward. What have we accomplished here? Well, we've got this code template that's under control. We've got this that replaces the pieces in the proper positions in the template, and that's probably, I think that's where it's going to end up. Now we're focused on this class that generates the intermediate, or uses the intermediate code to let us generate the real code. And the thing that's going on here, like true false, this is hard coded. This has to be different. Okay. Well, yeah, we'll see. This certainly has to be different. It's, this is all depends on the machine. This line probably is the same, probably just a constant, but this one is definitely different. Okay. Let's see. So we basically want to get back to this algorithm. So let's find the algorithm here. Okay, so compute these things. We've done step 1. Allocate an n+1 dimensional vector and initialize it with 1 and then all the rest zeros. Okay, well, we can do that. That's one of our steps. Okay, so here's our n+1 dimensional vector. All right, so if we just are parsing the string A, we have one, our size is 1, and so we have 2 items in the array. Okay, but we want this array to be true, false, 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 false. Now, I can see, let's see. The thing I know is you do have an array constructor that will repeat a value for you, and let's use that. Okay, so we're going to say, let's make an array code. We're going to test state declaration. State declaration initializes true and many falses. Yeah, I don't know. All right, so we'll let array code equal something. Well, it's got to be some sort of intermediate code. And it'll have to be a value we work out. Okay. And we want to initialize with it array code with the intermediate code. And we want to assert okay, well, the strategy I have, I know these values already, so it's let's assert, cannot find AEQ, come on, assert XCT test, assert equal, there you go. All right, so I'm somehow expecting to get var state of bool equals, and then I want true, false, false. Let's get 3 things in there, and I guess I'll separate with a space. False, false, bracket. Okay. And just to make this a touch more readable, this is going to be array code dot state declaration. Doesn't want to work with me here. Okay. We have to define our intermediate code. Okay. But first I want to convince myself the thing that matters is if I have 2 as my size, then I should get 3 fields in my state vector. Okay, this thing needs all these things. Okay, we'll let intermediate code equal intermediate code of all that stuff. There we go. All right, and I'm going to break out the lines again too. Original expression, I'm going to say doesn't matter. Count, that does matter. Count in this case is 2. Whoops. 2. Out positions, we don't care. I think I can just do this. And triggers, we don't care. Will that work? Okay. Okay. This should fail. We've only got 1 true false in there. Oh, set my timer. Assert equals state bool equals true false false is not equal to true false. Okay. 35, 70. Let's see, what time is it? 45. Okay. Yeah, that's kind of what we expected. All right, now this, we want this to work differently. So we want this thing to depend on the count, the intermediate code count. So we'll have to save it. Okay, now state declaration. This thing needs to be, let's get our pieces first. Okay, so basically the pieces I'm worried about is this inner declaration. So this thing is, well, we want it to be an array of strings. No, we want it to be a string separated by commas with true, false, 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 for however many of those things there are. All right, so if we say array repeating count. Okay, so I want to repeat false, and the count is int code dot. Come on, work with me here. Int code dot count. Is that right? Int code dot count. Yes. Okay, that will give us an array of falses, and then we did this before. Dot. It's the joined with separator string. That. Okay, so if we had that, we would have a list of all the falses. Result to call of joined separator is unused. Okay. Let false values equal that. Okay. And then in here, I'm just going to put that list. Okay. So I'm building up an array with a bunch of falses, exactly the right number, separating them with this, and returning the list, and then fitting it in with the true here. I think this should work. Okay. Now we want to do something similar. Okay, so this is the state 2 declaration. And I think what we would like initializes all false. All false. Okay, so back in our algorithm, it says you want basically F0 to 0 to match only from the first letter. That's really what we want. So 0 stands for false, and we're basically saying, can I match from anywhere? No, I have to match from the very first letter. So this algorithm could work for either exact matches or suffix matches. You know, you have a bunch of irrelevant stuff and then ABC that you're looking for. Okay, but we're just going to handle the case of all falses. All right, and we know what to do there. We can get by with that as our array. So it's array repeating false with a count of, and then that is int code dot count plus 1, because we want that first thing. It's n plus 1 entries. Okay, repeating that count and that. Okay, so that gives us an array of these things, I believe, if I got my quotes straightened out. Int code quote ends the array. Okay. And well, I guess I'm just gonna say return junk. Just to we do want to make sure our test is passing. Okay. So I could let's get the assertion right. I mean, it's complaining it wasn't junk, but is that what we want to do? I guess it's like, do we want to get those values now or let it generate them? See, the funny thing in Swift is you can't declare an array of a fixed size, as far as I know. You can assign it a size, and you can assign it this way a size, but you can't You can't say, oh, it's three things and don't do it. Now, I don't know, we do probably have append. Okay, at any rate, I'm saying I expected to initialize this with repeating false. I don't know. Count 3 parens. Okay, that's the code I expect. Okay. Repeating false is not equal to var state bool equals true false false. I'm calling the wrong thing, aren't I? State 2 declaration. You can see why we need to run our tests. At least at least I do. Oh man. And hit run test instead of run code. That's something else. Should still fail. Okay, let's hope it fails the right thing. Got junk. Yes. Okay, I'm calling the function I thought. Always test the test. Okay, so this false that. Run test should pass. Okay, what's the matter? False. Count 3. Var state. Oops, I've got state instead of state 2. I think I can live with that. Who failed? Oh. Code generation. Okay, so I'm changing the code, and I did kind of want to avoid doing too much of this, but I think this initialization is an improvement. It's sort of the only closest I can get, I guess. Count 3 parens. Okay, let's run them again. All right, so this is the test I mentioned, the test that we actually plug in our stuff into the thing. Okay, nuts. Boolean array repeating count false. Count 2. Did I not? Oh, for this one it should be 2. Yeah, because we only have one character, so the count of this is 1. Count plus 1 is 2, and that's what that should be. There's a nice quote from Ben Franklin. It's like, it's so lovely to be a rational creature because then I can find justification for anything to be whatever I want. But it really is supposed to be 2. Okay, let's get back to compiler tests. Yeah, so, and I think let's do a run here. We're kind of halfway, but I'm manipulating stuff in a way that makes it right for the code we're getting. So if I can say it that way, I do A and I compile. This should be perfectly acceptable in the matcher. So I'm just going to replace all this with what I just generated. Notice the repeating false. Okay. Oh yeah, so I got a bug there. That should be just false. Okay, so let's go back. So we don't want these quotes here, and we don't want them in code generation test either. Okay. And that's the problem with code generation or the challenge. You generate code, you can validate that you get the code you expected to, and that's the kind of validation we're doing. But you don't validate, it doesn't prove that the code is good or not. So I just got the code I expected and generated a type problem. All right. Oh, still had it. False. Did I? Oh, I didn't do it here either. Okay. Running unit tests. Make sure everybody's consistent. All right, now I'll run it. All right, so if I just do A, I got that code, looks good. Select all, paste. Okay, now it's happy. We'll run this one. Okay, so it's this two-step thing. I've got to generate the code that I expect, then I run, I build that code without errors. That's a good sign. But then if I want to know if it's working or not, I have to actually go test it. Okay, so A expects A, that's good. C, AC, no. Empty, doesn't accept it. Okay, so we're getting there. Okay, so this is state 2. The body's more challenging. Let's assert. I think this line is just fine, whatever it is. Okay, so I don't think I can. I can't really escape creating that intermediate code for this. That's too bad. So this one is update state. Test update state copies new to copy state to state. Okay, and this stuff is just to prove it's kind of arbitrary. None of this stuff is anything meaningful. All I'm trying to do is make sure I get state equals state 2. And this is array code dot update state. Should just pass. So I'm going to get into the hard part of the algorithm now. All right. So the initial position, let's get that one done. F0 equals 0. That's the state 2 sub 0 equals false. Okay, so that line is actually correct as is. We can initial state equals this. Okay. And maybe that should be a separate thing. I don't know. Let lines equal initial state and the rest. Okay, so in our case, we're always going to have state 2 is false, and we'll just return this. Okay, so we're returning initial state plus that. It should not break anything yet, or well, at all. Okay. All right, so let's make sure body incorporates trigger triggers. I don't know. This is the heart and the hard part, or a hard part. That's this step 4 here. So for each triple in our trigger set, define the rest of the next state functions. F of I is equal to x equals a and a bunch of ors of v sub j. And v sub j, j is all the things in H, okay, and v is our state vector. So in our code, we're looking at the old state. We're calculating the new state. We're only going to look at the old state. So let's go back here. In the loop, I update state 2 and then eventually copy state 2 to state. So I don't want some situation where I'm doing a partial, I can't just update state directly, because then when I reference it here, it's messed up. Okay, so this thing, and well, I'm going to say what do we call that? Next state calculations, next state transitions equal, and I'm going to take this. And then I will put I may want to mess around a little with this when we get there. I've got this thing as a constant string, and this thing is really going to be an array O stuff. So let's keep going. So I want to change this thing. Basically, my algorithm is I'm going to produce a bunch of lines like this. Okay, and so I'm going to do this. Let's make it into a bunch of lines. And then in here, we're returning, we're returning this. We'll make this better eventually. Dot append. Okay, so we're returning an array consisting of the initial state. Cannot return expression of type parens. Cannot convert expression of type string to expected element type string. Cannot use mutating member. Okay, well, let's do it this way. Let result equal this. Is that okay? Var. Okay, let's make sure nothing's blowing up out of all this. No? Contents of, okay, so this array, this next transitions, is really based on the trigger set. Let's go to intermediate code. Okay, so it's a set of trigger rows, and trigger rows for all this stuff that's here. The heart of it is it's just a class that knows position, character, positions. And if we go back to our algorithm, we're going to iterate through position, character, positions in the trigger set for the expression and define the next state functions out of that. Okay, so let's see. So let's make a intermediate code. Okay, irrelevant -1 out positions. It's not referenced here. It's used down here. Okay, so we can be empty. And then the triggers are interesting. Okay, so our triggers, they are a bunch of trigger rows. Moves to 1 on character A in positions 0 and 1. Okay, and then we'll add a second one. Trigger row moves to 2 on character B and the set of 2. Okay, so we'll do one with a one item and a multi-item. All right, our assertion then, assert equal. It's a big thing. Oh, come on. The selection is really bizarre. That's supposed to be a one word left. Okay, delete. Okay, this thing is array code dot body. Okay, cannot convert string to argument type string. Okay, well that's probably good. This is that. Okay, and the first thing we expect is that initial string thing. Is this. Is that. And then the second thing we expect is state 2, and then back to the rules. We're looking for assigning position I, so the trigger row position, and our test has a trigger row position of 1. So assign I equals, and then its character equals some character. Well, our character in this case is A. And then we say and then we're going to put some stuff. Okay. The stuff we're going to put is state sub 0 or state sub 1. Parentheses go after that, yes. And then we expect to see state 2 sub 2 equals character equals B, and the only thing we care about is state 2. And we'll assume it's parenthesized regardless. Okay. Instance, oops, that should be lowercase a. Okay. Now this, I guess I gotta copy that line too. This test should fail. Excuse me. Okay, so how did that pass? Okay, test body. I think sometimes you must like to watch me fail. We should have caught that between us, right? What are partners for? Okay, so the failure, we got state 2 equals false. State 1 that, state that is not equal to state 2 0 equals false. State 2 sub 1 character equals A, and state 0, we want 0 1. and we go on the second line. So it's got the hard-coded stuff, as you'd kind of expect. Okay, so now this, okay, I have an intuition about what's going to go wrong. Let's see if it happens. We're going to take the triggers, intermediate code dot triggers, okay, and our job is to iterate over them, right? So again, the algorithm is basically iterate over each triple in the trigger set. So we're doing that. For each trigger, I'm gonna map to a string, and the string is gonna look something like this. Okay. Let's map, and okay, I'm gonna comment out this. Okay. So what are you gonna produce? Well, we don't have to have that if we use $0, so I'll use $0. Okay, so I'm going to produce something that looks a lot like this. Okay, but where we have one, that's my I. All right, and that comes from the trigger. So the trigger is $0, $0 dot, okay, and it moves to position. Okay, so state 2 moves to this position if the character equals, and it's not going to be A, sorry, it's not going to be A, it's going to be something out of the triggers. And I don't know, you tell me, maybe trigger would be helpful here. We're using this thing a lot. Got trigger.moves position and trigger.character. Okay, and then let's give ourselves a helper function. Okay, all right. So character equals trigger character, and let's let something else compute this stuff. Okay, so and I'm just gonna say helper. Passing in trigger, and that's we don't have a helper yet. Okay, let's define it. Function helper returns string, and the stuff I deleted. What I deleted just now was state sub 0 in there. Okay, so we're keeping the parentheses we're providing, but state 0 and then or state 1 or state 2. Okay, and this is a string. Okay, what's wrong? Invalid escape sequence. Okay, character equals trigger.character slash question. Oh, I got this inside. Helper trigger. That ends the call. That ends the helper. And we need one more. Okay. What else is on? Argument passed to call. It takes no arguments. Oh, well. Let's give this a trigger row. Trigger of type trigger row. Okay. Should still fail, but it's going to be slightly better. It's going to have iterated through my list, I hope. But each one will stay state 0 instead of the and. Okay. And is my expectation wrong? State 2 is false. That's fine. State 2 sub 1 is character equals A and state 0 or state 1. State 2 equals character equals B and state 2. Well, we just hard code state 0. Okay. We're ready for a break, so we'll take a couple minutes and see you then. All right, we're getting there. Welcome back. All right, so we're close that we've got the right number of rows in our list coming back, but the state calculations are messed up because this helper function is not doing its job. And let's name this thing. Let's see. It's really I don't know, positions. Let's call it possible positions, current positions. Let's try that again. I'm going to say current positions for trigger. And we may not need all of trigger. I mean, really what we need is the set of positions. And this is set of int. Okay, should still fail, of course. Okay, so what we want to do with our set of positions, we're basically trying to say position or position or position. Okay, and so let's see. So I think the way to do that is we're going to map those things. Map. And then for each one, we're going to say state sub $0. Okay, so it's some integer, and that's in converted. Okay, so convert the integer to a string and return a list of those. All right, and then I think we can do joined with our separator. Okay. And I think that does get a string. Yeah. Okay. So we had state sub 0. So state, take the position. Basically, we're taking the list of positions, turn it into a list of state sub i's, where I is the position, and then join them together with the OR bars and get what we want. Okay, and then I usually try and do things top to bottom, at least helper functions right beneath the one that uses them, and otherwise sort of top down kind of by default, for what it's worth. Should pass. You got to be confident. Oh, okay. What do we got? Array code. So we got state 2 equals false. This one's state 0 or 1, state 0 or state 1, quote, comma, quote. State 2 is character equals B. Wait a minute. This is A. False. We got A with state 0 or 1. And B with state 2. Is that right? What did our trigger look like? A 0 or 1. B is state 2. Okay, that. It would be nice if I could just put this somewhere and see it much more lined up. I think I can copy it. Okay, so I'll paste this, assert failed, state 2 equals false. equals false, and that, okay, is not equal to, I'm just going to separate these. All right, so this one, state 2 equals false. That is there. Okay, that one's okay. State 2 equals false. State 2 sub 1 equals that. I'm putting the second one second. Just saying. Get the prefix. It's certainly possible to be off by characters. State 2, well, we don't care about the garbage at the end, but yeah. Okay, what am I missing? I got an equals. I think that's in my expectations, isn't it? Sure enough. Okay. Ugh. So yeah, that's a pattern I got sometimes. You run a test to see it fail. It fails because you were calling the wrong thing. And then you run it again to see it pass, and it fails because it's not right in the first place. Like, oh, okay. What else lined up here? So we had one character difference. If I put that character in, equals that. That looks pretty darn close to me. State 2, 1, 0, 1, 0. Sorry, 2, 2. Okay. State 2, 0 equals false. State 2, 1 equals character equals A, and state 0 or 1. Okay, state 2 sub 0 equals false. State 2 equals character equals A, and state 1 or 0. Okay, this is what I was afraid of. They're both legitimately equal, but because it's a set, it's allowed to just pick whichever order it wanted, and it decided I would do 1 before 0. So I'm going to sort these. I think I can just say sort or sorted. Sorted. Yeah. Okay. So kind of enforcing the order I want, I guess. I mean, no I guess about it. It's okay. Cool. That's a big step. All right, so we've implemented this step 4 in our algorithm now. We run through all the triggers. We generate these clauses. Each clause is a test and a bunch of ORs together. X is current input value, that's CH in our set. Now we need to check the output function. So which states are possible termination points? So if I look here, in this example, AB or B star BA, the only way to get out, you have to go through the BA at the end. So the only termination point is 5. Okay, but if I had just AB or B, I could, and no star, just AB or B, I could either terminate here, which is 2, or here, which is 3. So I have to test for all the possibilities. Okay, so it's an OR of all those possibilities. Okay. Let's get a test for that. And this is the, I think, update state we're happy with. This is return value. Func test return value considers all possible end positions. And again, that's kind of the heart of this algorithm is if I can keep track of all the possible positions I could be in, and then keep track of how these transitions affect those possible positions, then I'm good. Okay, so we're going to take this again. Intermediate code. Now this time we're using the out positions. All right, so I think all we're looking at is for things in the out, we're gonna iterate over those or those together and return that. Okay, so instead of return state one or this or that or the other. Okay, and I think this guy looks really helpful. Okay, so let's make our out positions be 1, 2, and this thing will always have something. We don't allow empty. The way we define regular expressions, we always have at least one letter, and so there will always be at least one position that is the final place. And actually, position 0 is often, if it could be empty, position 0 will be in there. So you're always guaranteed at least one and possibly 2 or more. Okay, so out position set 2. We don't care about these other things, so I'm going to leave them as irrelevant. And we're going to assert equals. So what do we expect in this case? Well, we expect state sub 1 or state sub 2. And that's coming from array code dot return value. All right, again, should fail. Have I failed for the right reason? I'm calling the right thing this time. I'm passing in the output positions. Okay. One failure. All right. And he looks like always returns 1. Okay. But now I think we can just use current positions, this current positions map. We're going to return... Well, we're really going to return that. We're going to return current positions of trigger. Intermediate code dot out positions. Okay. This thing returns a string that we need for that. All right, it should pass. Sometimes they get faster and faster. That's good. I know there's a lot of moving parts here, but and it's our main code, is it? Let's see. State 0 or 1. Body incorporates triggers. Okay, if the trigger rows... Oh, yeah, it will change the out. Well, no, it shouldn't change this. State 2 equals false. That's there. State 2 equals character equals state 2 sub 2, state 2 sub 1. State 2 sub 1, state 2 sub 2. Okay, it is that same set problem. Oof. All right, let's get back here. Interestingly, this passes, okay, because this thing already sorts. The real thing is this thing does not pass. The body, this thing does not sort. So the triggers, and we got to be consistent. Either we have to make sure it's consistent coming out, or we have to be prepared for any possible sort order in the result set. And since we've already converted it to strings, it's really going to be painful to figure out the unsorted. But let's do dot sorted, and then I guess by we can say I'm going to find an example of this or some. Let's see. Oops. Hey, sorry, I always forget to look over at the at the chat. Hello. Okay. So let's see. I'm going to pull a window over. Swift sorted example. I mean, yeah, I think we just have to give it a less than operator. And we should be able to just do it in line. Sorted. So 0, 1, if A less than B, yeah, we can do that. We don't have a less than operator in our trigger rows. Let's see. Okay. I don't know if this is getting too hard to read. Let's pull this down. Let's pull this down. Okay, so it's sorted by trigger row. So $0, $1. Okay, so if $0 dot, oh come on, here a trigger row. I'm going to say this doesn't fail to sort. Let's see. So by $0 dot, no, you're still not going to provide it for me. $0 dot. Well, it's in our trigger stuff. It's 2 trigger rows. It's really the trigger row. Basically, we're saying position. We'll do by position first. Moves to position. Sorry. Okay. Now, I think do you want to volunteer to do something about that? I thought I needed a try there somewhere, but okay, I guess it's all right. The question is, do these things come out in order? So here, can we get the same one twice? And I think basically we won't. So I think this thing will be enough. We could mix in the character as well. So I know we would never have the. Would we ever have those duplicating? I don't think we would. Let's go with this and see where we are. But I think by construction we're only going to generate one per position because we're generating all the stuff from that position. Okay. We're kind of at a moment of truth here. So let's see what happens. So I think we've got everything in. So if we take that giant example, A, B, or B star, followed by B, A, and we compile that, we get this code. Whoops. hope it copied it and left it there for me. Paste that. Okay. Yeah, we get that code. And zeros false, A, B, 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 A, 0, 1, 2, 3, 4, 5. Let's go back to our real code, or the other guy's generated code. Dewan's used the C++, but he's got 0, 1, 2, 3, 4, 5, A, B, 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 A, 0, 2, 3, 1, 0, 2, 3, 0, 2, 3, 4. 0, 2, 3, 1, 0, 2, 3, 0, 2, 3, 4. So I believe our code matches his. And let's run this, and we'll run the green one. And hopefully with you know, knock on wood or whatever. Okay, so a valid string for this. Well, the famous band ABBA is a valid string. And if you wanted to do, let's see, you could do A, B, A, B, A, B, A, B, 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 A. As long as it ends B, A, I think we're good. You can throw in B's after the AB. So A, B, 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 B should be fine. But if you throw in A, B, B, AA, there's no way you can get a valid AA. Okay, so if I have two A's in a row, not good. Okay, empty string, not acceptable. You got to have BA. Just A, not acceptable. Okay, so it's been a long week. Let's see what we got here. Yeah, like I said, I'm not so good at the chat. So I do see, hey, Vimo4. I'm gonna have to figure out a way to get these all in one window, because I do tend not to look over there. Sorry. But at any rate, hopefully you can see what we've kind of just finished. It's this regular expression compiler. So we give it a regular expression. It turns that into Swift code, which is relatively, I would say, relatively obscure Swift code. It's not obvious to me that this matches that string without really analyzing it deeply. But this code is now code we could put into another program and use it to match these strings. All right, so let's try a different string. Hello. I don't know. That's pretty good. Hello. Let's let you have lots of O's and a W if you want. Hello W world. Okay, and if we compile that, again we get a pretty complicated expression. It put it in the paste buffer for me, so I go over here, paste it. Okay, and we run this and see if we can get the acceptable stuff. Okay, so hello world is acceptable. Hello world with lots of O's should be acceptable. Hello world with a W before the world, two worlds, two W's is good, but a bunch of W's is not. Okay, so I think we're at a good point here. Okay, so as far as the algorithm in the paper, we've generated the code that corresponds to this. Now, his original algorithm, he used zeros and ones. We switched them to being Booleans, and I think that's okay. We did this stuff with the array. You know, we generated it up here, hard coded. Down here, we use this repeating thing. It's minor, relatively minor difference. It probably, yeah, I don't know. It may help something along the way. I mean, really, we don't care what these values are, because notice we're replacing every single one of them. Okay, so the 12 values, 0 through 11. All right, now let's take a time check here. Okay, so we got about 15 minutes. So I'm going to skip testing and just do. All right. So let me I want to explore this other approach I'm talking about. So instead of calling this array code, let's rename it. I don't know. This is just state code. Okay, because it's all the state stuff basically. All right, so what I'm going to do is I'm going to make my own class. Instead of array code, I'm going to make a new class, and I'm just going to hard code in and just try and get this working directly just to avoid the TDD. It's just kind of a, call it a spike if you want. It's going to look a lot like array code. It's going to have the same functions and everything else. Okay, so intermediate, it takes intermediate code. It's got to have these same functions because I'm gonna replace it in here. So we're gonna call bit flag code. All right, and should have passed all tests. I just in effect switched in a class, but all the stuff's the same. All right, now my observation when I look at our generated code, I got a bunch of booleans in an array. I think like, okay, could those just be bit flags? You know, so instead of array sub 0, I want to get flag sub 0. And you know, the basically it's the rightmost bit if I think of a 64-bit unsigned bit. So I'm kind of putting on a compiler or assembly level hat here in a way, but an array of booleans, if you know it's smaller than your word length, you can do it with flags just as easily. So let's try that. And I had drafted out what it would be, but I'm just gonna modify it. So I'm gonna say the state is gonna be a uint 64. Oops, 64. That's a Swift type. And I'm gonna, instead of these values, that equals 0. Okay, so that had one true and all falses. So the 1 slot sub 0 is 1, while slot sub 0 is really the rightmost bit, which is a 1 bit. Okay, so it just equals 1. All right. The second one, state 2, well, he's got to be the same type, 64, and he's all falses. All right, now in binary, that's all 0 flags. Okay, so it's a 0. State 2 sub 0 equals false. Well, that's actually redundant. It doesn't, we don't really need it. Okay, so I'm going to get rid of that piece. All right, now these things, let's just return result. Return next state transitions. Okay. All right. So my thing here is I'm going to take the encode triggers. Instead of saying state 2 sub I, okay, if I'm doing this with binary, to assign just one bit, I basically use or equals. Okay, so I'm going to say state 2. Well, if I say, I almost want to flip it around. I want to say if the character if these things are all true, then change the bit position. So I'll just copy this for a moment. Okay, so I want to say if this stuff, character equals that and all those positions. I'll comment these briefly. Okay, if character equals position and current positions, let's see, where's this one going? Current positions of trigger positions, then state2 sub something or equals 1. Okay, so if those things are on, then we're going to set it to true. Okay, before it computed a Boolean expression and set it in the value, we're going to just change the bit. Okay, and we have to, this has to be something. It has to be 1 left shifted by something. Well, it's got to be trigger.moves to position. Okay, so we're saying if you find the right character and you're in the right position, then go ahead and make this move. All right, and we'll return that. Okay, my current positions, state sub I is really state and dollar, no. Well, I'll get something here. All right, so state and $0 is a position, so it's an int. So this is 1 less than or shift left by $0. Okay. And I can separate these by OR bars instead. Let's put some parentheses in there. Well, let's do this for now. I think that'll be okay. State equals state2 is fine, and then this thing should be okay too. State and this or that or that. Okay. Yeah, I'm gonna parenthesize this for now. Okay. I'm gonna run this and we'll see if we get out clean. All right, so I'm going to go back to A, B, or B, star, followed by BA. Okay, so it uses several different operators. All right, I get some code. It looks missing a right brace. Okay. Position state2 equals trigger.moves to position brace. Okay. Now this kind of compiler person hat you got to wear. You're constantly considering the template you're going to, and you get the template and you got to figure out if it actually works or not and all that. So A, B, or B, star, BA. Compile that. Okay, I think that looks like legit code. So we'll go over here, paste it. It doesn't complain. Oh no, it does. Cannot be used as a Boolean. Oh, I got to test for not equals 0. So state and this not equals 0. Yeah, it's easy to get used to something like C, where you can kind of flip these types around pretty quick. It'll let you mix and match a little bit more. Okay, we got that. Paste that in here. Okay, no complaints this time. All right, so A, B, and B. So ABA, yep, ABA, A, B, B, A, B, B, A. Yep, but certainly nothing with an X, and certainly nothing ending in two A's. Okay, so I'm getting there. If I look at this code, well, I can do better. So what I see is state 1, 0, 1 less than 2, 1 less than 3. I should be able to combine that. I think I want to get them in braces. I should be able to say 1 less than 0 or bar, 1 less than 2 or bar, or 1 less than 3. And that's probably efficient enough. Okay, so let's go back here. Okay, so state and. So really the state and, I'm going to pull that out. So if I just spit out this stuff with bars in the middle, okay, that gives me a the suffix equals that, and then I can put return state and, well, suffix is a bad name. Let's say terms. Suffix and parenthesis, then the terms, parenthesis, not equal 0. And I may just to fully parenthesize things and make sure I'm not messing my operators up, because I'm just not 100% sure. Okay, so now I'm optimizing. All right, so instead of these multiple computations, I want them to fold into one computation. So it's a slight optimization. I guess it's not a major optimization. B star, let's do BAC just to be different. Okay, so now I see state and 1 less than 0, not equals 0. No, I got too many not equal zeros in there. Oh, yeah. 1 and, so this is 1 bit. 1 and that, or, okay. Okay, so state and 1 or 1 left it shifted 0, 1 left it shifted 2, 3. That state equals 1 or that. Yeah, that looks better. Okay. Replace this and hopefully it looks good. And let's test it. All right, so this definitely could go further. I mean, instead of spitting out this thing, I could probably spit out a binary constant or a hex constant. I think they let you do 0b110001 kind of stuff in Swift as a constant name. But in reality, the compiler is able to fold this together. It says, oh, you're a numeric constant 1, you're a numeric constant 2, you're a numeric constant to 3 is 8, okay, or 1, 0, 1, 4, and 8, okay. Still building. Okay, well, I'm gonna go back here while we're doing that. So let me find the actual out algorithms. Here we go. Okay, so we built this compiler with somewhat folded stages, but parsing, semantic analysis, intermediate code generation is really generating that trigger set, and final code generation spitting out the Swift. We used recursive descent, parsing to build trees of these things. And then we numbered the letters, so you know every position in the expression. We figured out which positions or which expressions could be empty. So if you're matching a letter, you're never empty because a letter is always going to be at least one character. If you're matching an or bar or union of two things, well, if either one can be empty, then you could be empty. In the and case, the sequential, it only is empty if you're both empty. And then repetition, a zero or more can be empty. One or more, it's empty if its child is empty, and zero or more can be empty. So the skip function. We have the out function that figures out what positions could you be in at the end of this tree, and then we build up this trigger function that says where are you? You know what given these positions, what positions could you go to next? And that turned into we use this algorithm and turn it into code, and in our case, Swift code. Okay. All right, so that last experiment wasn't good, but we can go back to this one. Is fine. But I did a quick spike at the end to say, can I generate bit-oriented code instead? And if my expression is small enough, then yes, that is all going to work. So I'm very happy with how this came out. It took longer to do the parsing than I thought it would, but the functions were pretty straightforward. You had to develop test cases for all those things, but it worked out okay. So if you join me for any or all, thanks very much. I hope you got something out of it. And next week I'll be Tuesday, Thursday, 1 to 3 p.m., Wednesday morning, 9 to 11:30 a.m., all times Eastern time, and back on a sort tables data viewer that I've been working on. So bye-bye. Thanks.